In this video, we'll talk about the natural exponential function and the logarithmic function. Please read and watch the videos and read through the lesson and to be reminded what the exponential function e to the x looks like when graphed. Take a look at the graph of ln of x and keep in mind that if ln of x equals y, then x can be written as e to the y. So this would be the logarithmic form, and this would be the exponential form. So four important formulas that you need to use in this lesson are the derivative. Let's maybe start with the derivative of e to the x. It's just e to the x. As the integral of e to the x dx is e to the x plus c. Now, if you have to calculate the derivative of e to u of x, which would be something like e to sine of x, for example, or e to x squared plus 2x plus 2, for example. So not just e to the x. Well, you'll have to use the chain rule, which means e to the u times u prime of x. So, and two more formulas. The derivative of the ln of x is 1 over x, and the integral of 1 over x dx is ln of absolute value of x plus c. So let's do a few problems. The derivative of ln of 7x, well, again, ln of x prime, we have it's 1 over x, so ln of u of x prime, right? So the derivative of the composed function, and not just x, is going to be 1 over u of x times u prime of x. So in our case, we have ln of 7x, so 7x is our u of x, so it's going to be 1 over 7x times 7x prime. So that's 1 over 7x times 7. The two 7 cancel each other, and we get 1 over x. This would be the whole solution. I just wrote other stuff on the side. Let's take a look at the next problem. Compute the derivative of x to the e plus e to the x. So very interesting, right? That means let's differentiate this one separately and then differentiate e to the x prime. Now x to e prime, if it's a little bit confusing, well, let's think, what if it was x to the second prime? We would just use a power rule, so it would be 2x to the first, right? So e, it's a number, it's a constant. So what we get when we differentiate, well, we use power rule, so it's e, x to e minus 1, and then e to the x prime, it's exactly e to the x. So this would be our answer. Let's take a look at the next problem. The next problem is ln of x over ln of x plus 1 prime, so we have to differentiate these. Now, we notice that there is a division, so let's remember the quotient rule. F over g prime, it's f prime g minus f g prime over g squared. So in our case, it's going to be ln of x prime times ln of x plus 1 minus ln of x times ln of x plus 1 prime, everything over ln of x plus 1 squared. I just want to make sure it's clear. These are two terms. Ln of x is one term and 1 is another. If I wanted to have ln of x of the quantity x plus 1, we would have put ln of x plus 1. So this is different than ln of x plus 1. This you calculate these two first and then apply ln. Here we have to do ln of x first and then add a 1. I hope it makes sense. So now let's calculate it. ln of x prime is 1 over x, and then times ln of x plus 1. I'm going to erase this to make room. Minus ln of x times ln of x prime is 1 over x, and then 1 prime is 0, so I can open the parentheses, over ln of x plus 1 squared. So if I open the parentheses at the numerator, I get 1 over x ln of x plus 1 over x. I multiply this by each term, minus ln of x over x, everything over ln of x plus 1 squared. Now this is the same quantity, opposite signs, and we know that a over b over c, it's actually a over bc. So it's going to be 1 over x times ln of x plus 1 squared. This would be the final answer. Let's take a look at another problem, an integral. So we have integral from 0 to pi over 2 sine of x over 1 plus cosine of x dx. So how do we solve this one? Well, how about we use substitution and we say u equals 1 plus cosine of x. If we want to find the differential du, because here we have dx, so once we change the variable, then we have to change the differential as well. So du, it's negative sine of x dx. So we notice that this sine of x dx, it's the whole thing at the numerator there. So I'm going to say integral of negative du, because x or sine of x dx, it's actually negative du, over u. Well, I could change the integration interval. I could say if x equals 0, then u is going to be 1 plus cosine of 0, so u is going to be 2. So the new integral, the new limit of integration is 2. If x equals pi over 2, u is 1 plus cosine of pi over 2. Now cosine of pi over 2 is 0, so 1. So now the integral is from 2 to 1 of negative du over u. I can factor out the negative, and now integral of du over u, it's ln of absolute value of u, evaluated from 2 to 1. So we get negative ln of 1. I can drop the absolute value sign because absolute value of 1 is 1. Minus from the fundamental theorem of calculus, but because I have minus here, I'm going to put plus ln of 2. ln of 1 is 0, so the final answer is ln of 2. And that's it for that problem. Now let's take a look at the next problem. Compute integral of e to the x plus e to negative x over e to the x minus e to negative x. So I'm going to try again substitution. How about e to the x minus e to negative x? We set it equal to u, so the denominator. So du, the differential, is e to the x plus e to negative x dx, which is exactly the numerator. So what does that mean? It means this equal to du over u. Again, we don't have limits of integration, so I'm just going to leave it as undetermined, undefined integral. So we get ln of absolute value of u plus c, but now let's replace back u meant e to the x minus e to negative x plus c. And we have the absolute value because we can get a negative number there. Okay, let's see another one. Compute integral of ln squared of x plus 2 ln of x minus 1 over x dx. Okay, now when I take a step back and I look at the integral, I see ln and I see x at the denominator. So I'm thinking that ln of x prime is 1 over x. So what if I write this integral as ln squared of x plus 2 ln of x minus 1 times 1 over x dx. So instead of having that x at the denominator, I have it 1 over x separately. If I say that ln of x is u, or u equals ln of x, if we differentiate, if we want to find the differential, it's going to be 1 over x dx, it's equal to du. So you see how by writing it separately, I can emphasize that what I highlighted in yellow, it's actually du. So now ln squared of x is going to be u squared plus 2u minus 1 du. So we can calculate this, u to the third over 3 plus 2u squared over 2 minus u plus c, and let's replace back u being ln of x. So we have ln to the third of x over 3 plus these two cancels, ln squared of x minus ln of x plus c, final answer. I just want to remind you that ln squared of x is not the same thing as ln x squared like that. But this is the same thing with ln of x squared in this form. Okay, and let's take a look at the last problem, logarithmic differentiation. So if we have to differentiate this function f of x equals x to the x, right, how do we differentiate this? Because this function, well, it reminds me of x to the n prime, which is n x to n minus 1, but it also reminds me that a to the x prime is a to the x ln of a, but it is a combination of both of them, right? So how do we do that? Well, there are a few more ways to do it, but let's stick to the logarithmic differentiation, and we'll do the other way as an alternative to check our answer. So logarithmic differentiation works like this. We write our function in the form f of x equals x to the x, and then we apply ln to both sides. So we are going to get ln of f of x equals ln of x to the x. But we have a property that says this x will come in front of the ln. So ln of f of x is equal to x ln of x. Now let's differentiate with respect to x, both sides. So WRT with respect to. So if we differentiate, we get ln of f of x prime, it's f prime of x over f of x. Chain rule, right? Think of ln of x prime is 1 over x, but ln of u of x prime is u prime of x over u of x. Well, I don't have u, I have f. Equals, and here I have two functions, so I'm going to use product rule. So it's x prime, which is 1 ln of x, plus x not prime, and ln of x prime, which is 1 over x. So we end up with f prime of x over f of x equals ln of x plus 1. If we multiply both sides by f of x, we end up with f prime of x equals f of x times ln of x plus 1. But we know f of x, so f prime of x, it's x to the x, ln of x plus 1. And this is the answer using logarithmic differentiation. But I want to do this problem in one more way. So if we have f of x equals x to the x, I'm going to rewrite x to the x as base e. So e to ln of x to the x. So it's e to x ln of x. Now how do we differentiate this? Well, we write ex to ln of x prime. So I'm going to use e to u of x prime. It's actually e to u of x times u prime of x. So in our case, it's going to be e to x ln of x times x ln of x prime. E to x ln of x means x to x, because that's how we started, and x ln of x prime, it's using product rule, so it's ln of x plus 1. So we got exactly the same thing. We compare them, but we use different methods. So be very careful. Depending on how the problem, what the problem says, you have to follow those directions. So if it just says differentiate this, then you can differentiate it with any form, or method. But if it specifies differentiate using logarithmic differentiation, then you will have to use the first method that I used here. I hope this helps.